Hello and welcome to another webinar session. Thank you for taking time and joining the webinar. So today's webinar is about designing industrial IoT architecture for your IoT projects. And my name is Abhishek and I'm part of the marketing and sales team at Factana. So for those who are joining us for the first time, so I'll quickly give a brief introduction about Factana. And again, for those who have been a part of our previous webinars, we are glad to have you with us today again. Thank you so much for joining. So Factana is a Industry 4.0 solution provider. Factana has been supporting various small, medium, and large enterprises to adopt Industry 4.0 and digitalize manufacturing solutions. We are a global company with operations in India, Europe, and USA. And Fogwing is our Industry 4.0 platform offering digital solution for IoT device management, asset performance management, and smart manufacturing. So let's get started with the webinar. This webinar will be presented by the founder and chief of Factana, Mr. Hariharan Ganesh. And before jumping into the webinar, a quick note to all. Those who have questions, please do not hesitate. Just shoot your questions through the chat options. All the questions will be answered towards the end of the webinar. So without further ado, Hari, over to you.
Thank you, Abhishek. Hello, everyone. Good evening, good morning, good afternoon, wherever you are connecting. And whenever you are watching this webinar in our YouTube channel, obviously this webinar will be available in our YouTube channel after this session is over. Once again, thanks for joining. And today's topic, we would like to talk about industrial IoT architecture and how do we design it and what services available on the field and how do we go and validate the services and things like that. One of the reason begin for this session itself is as many people asking us on why we built the IoT platform while already the popular IoT services provided by Google, Azure, and AWS. So we wanted to answer this question through this webinar as well. At the same time, we want to give honest insights about various services provided by the top 3 cloud providers, as well as what we are providing and how we are differentiating from them. So before I jump into the into the architecture, just to make sure everybody in the context, and every webinars we keep repeating this to make sure that we are in a clear understanding about the industrial IoT. Generally, IoT is a very hot topic in the market, and obviously there are various different use cases can be addressed with the help of IoT solution. But explicitly, we are focusing on industrial IoT as we are as a company providing Industry 4.0 solutions for the small, medium, and larger enterprises. Generally, in IoT, it's a combination of device, hardware, device, and the cloud connectivity to share the information. But industrial IoT is more going deeper into the space of industrial systems, connecting with industrial systems, and serving taking the data from the industrial system, which are mostly complicated systems, data that generated by the machines in the factories, and bring that to the common environment and make that available to the users and consumers of the business side. So typically, industrial IoT involves in machines, reading data from the machines. That's a key differentiation. Routing the data in a different mode through various connectivity, cloud service solutions. And from there, how do we identify the insights and then presenting to the users, or the user consuming the data that gives them the insights about how the factory and machines operating, as well as the process and monitoring aspect of that. There are various industrial automation requirements can also be addressed, especially when in the need of remote automation, remote control based monitoring or automation solutions required industry IoT. And of course, industrial IoT is a foundation for the to build the industry 4.0 solutions for digitalizing the manufacturing or any other industrial cases. So in general, it's required device connectivity, cloud services to build any IoT solution. But since the context is all about industrial IoT, and we are going to talk about how this is going to be applied to the industrial cases, it's very important for us to understand the different level of industrial systems that being in practice on the manufacturing or any other larger production based environment, and how these systems are involved in the IoT connectivity, or basically in the connectivity standpoint. So try to understand what are the different systems. So we'll go from the bottom to top. Generally, manufacturing units, machineries, either fully automated or semi-automated, or manual-based machineries. Either case of that, there are various machines available in the manufacturing sector. Of course, these machines are bought and used by the manufacturers over the period of time, over the years. So there may be option in the machines to read the data. Maybe there may be a sensors there, but reading analog information from the machines. There may be a digital information from the machines, and through various sensors or controllers that reading that various parameters from the machines. In the modern machines that are being installed on the factories or the industrial cases are already equipped with more sensor capabilities and reading various parameters and identifying various metrics out of that. However, is still limited to the local premises available only within the factory environment. The machines that are installed over the years, like 10 years, 15 years back, or 20 years back, the machines installed may not have the sensors to read the data, so which are required additional sensors to read the data from those machines. So machines are the bottom level of systems. On top of that, whether inbuilt sensors, connectors, controllers, or the retrofit sensors that we physically fit into the machineries to read the data to measure the various parameters of the system operations or machine operations. On top of that, the controlling units, the most commonly widely used, the PLC systems, programming logically controlled systems, which are programmed to control the system to automate or semi-automate the system functionalities. And those PLC programs already have, or the systems already have the information about the machine operation, machine running time, machine internal challenges and other things. I mean, internal data and other things and all. Then on top of that, there are many manufacturing and other industrial customers are using SCADA systems to consolidate the data that generated by the machines locally, and then using that for supervision purpose. And there are HMI systems that allow to visually see the function of the system and the machines operating on that environment, and how do we control that through visual aspect of that. So that's part of the SCADA and HMI systems that also are being available in the industry. And most of the cases, when the system are capable of, or the machines are capable of providing those data to the PLC system, then it is easy to build the PLC and SCADA environment. The customer who has up to the SCADA environment, is easy for us to read the data from there and push it to the external usage or systems that are available in the manufacturing sector, such as ERP, CRM systems, or some kind of planning systems which required such information from the operational environment can also be connected with that system. And of course, it's all locally connected or maybe limited to the network area within the organization. Whole purpose of going into digital and whole purpose of going into industrial or IoT based connectivity is to bring the data available to the common place, not locally but globally, make it available so that anywhere, anytime, the business operations, business users can review and do the quick visualization of the factory production operation or internal business operation aspect of that. So the availability of the data across geo is the key for the initiatives on the industrial IoT aspect of that. But how, where the IoT comes into picture in this total landscape? So IoT is, as I said, it's connecting the missions to get the data and make it available for any systems, existing information system, or the users across the region. Industrial IoT is a glue. Generally, we call it as a glue, which connects the operating technologies, which are mostly on the PLC SCADA systems, to the information technology systems, which are hosted on the cloud, maybe on the corporate centers and wherever it is, getting connected through the one. So in this model, it helps to get the data at real time from the factory floors and push the data to the available systems, information systems, real time, for real time analysis of the data, real-time identification of the performance, and real-time actions can be taken by the operational team as well as the business leaders, and more accurately. And that's a model and scale of achieving the industry, digitalizing the industry. And not just that, beyond that, these information can be used to make operational alignment. These information can be used to make more accurate automation in the process, as well as sharing the information to consumers and other third parties for global collaborations and other things. So to look into the benefit of taking this data out is enormous, as well as it's giving more value to the business. And that's the whole purpose of adapting the IoT based solutions here. So now we know IoT means what involves in IoT, right? So basically we are talking today to talk about IoT architecture or industrial IoT architecture, and we know that the systems are there, right? Now we are blowing that down to see what is mean by industrial IoT means, and what kind of different things are required to build the IoT, to take the data from the real time from the factory floors or any other industrial cases, and how we can push the data, and what are the various level of modules or components required to take this data to available to the digital platforms. So let's start from the bottom to top. The sensors and controllers, obviously they are the key to read the information, to measure the information or read the information from the machineries or the operating environment. Any systems, machines, or motors, anything that data we want to read, that we need sensors and controllers. Obviously, if it is a PLC SCADA systems, these controllers are inbuilt with that, are the modern systems which are built with automation, pre-built with automation. Those systems already have that kind of interfaces for us to read the data from the system. However, whether it's a system is already equipped or the machine is already equipped to provide the data directly, or we have to feed the sensors into the machineries or the equipments, we still need a mediator to collect the data from those sensors and controllers and push that to the cloud infrastructure for global data availability, right? Why we are going to the cloud? Because we want to take it to the cloud to make it available globally. Different region, different operational environments can access this data available. That's the whole purpose of taking to the cloud. And to do that, the next level is the gateways. What is gateways? The gateways are IoT gateways, are devices, are nodes. There are various combinations on that for the various use cases. The gateways, nodes, and edges are the one that connecting to the machine and getting the data, or connecting to the sensor or PLC systems to get the data from it, and then push the data into the to the cloud through the connectivity, to the wireless or wired, or through the internet connectivity, right? Any other mode. So gateways are the devices that we deploy on the field, which basically connecting to the physical environment to read the data, collect the data from it, either directly, indirectly collect it, and then making the data, pushing the data to the cloud. To do that, it requires a connectivity, right? The internet connectivity. In that case, IoT connectivity comes into picture, and we will talk about that in subsequent slides. IoT connectivity is basically, there are various type of IoT connectivities available. Depends on the different use cases, we have to use a different connectivity. Generally, these connectivities are helping us to take the data to the cloud through the internet. So in a factory environment, think about that in the factory environment or any other remote industrial or operating environment where may and may not be equipped with all the internet facilities, but still need when the connectivity to push the data to the cloud. Then the wireless communications technology or telecommunication technology can be used, such as 3G, 4G network can be used to push the data to the cloud. On the cloud side, now we are moving from the physical to the cloud, right? I mean, from the localized to the globalized environment. So which is on the cloud. On the cloud side, to receive this data that being sent by the gateways, we required some kind of channel. The channel also called as a gateway there in the cloud side. It's a gate to enter into the cloud infrastructure. So these gateways are providing support or protocols or connectivity or open, providing kind of a communication protocol to support the gateways to connect to that. So the gateway, cloud gateway, and the IoT gateway that physically located on the environment has to communicate in the common protocol. And there are various type of IoT gateway, various type of cloud gateways are available, depending on the different providers who providing and what type of gateway. Generally, there are standard protocols being used in the industrial cases. We will talk about that as well in later part. But generally, the model of cloud gateway is to receive the data from the IoT gateways in a sequential and make sure that those data are preserved for processing. So that's once the gateway receives the data, then the data has to be preserved and also to be processed. So that's where the data processing or storage capability is required on the cloud, because the machine may send large volume of data. Most of them are machine data, and some of cases, those data may not be directly meaningful to the users. So we may need to do the data processing to filter the data and extracting the required information from the data, and then storing that relevant data in the system and doing some insights analysis and other things and also, right? So all of them is required. So we need to have a data processing layer for processing the data, filtering, cleaning, enriching, and then storing the data for users. So once we store the data, then we are moving into the next level, right? So to distribute the data, because as we have seen in the previous slide, the data distribution is very important, because obviously that's the purpose of collecting the data, right? And these data should go into the information systems, which are like ERP, CRM systems, or any other business system that being used by the business users. We have to deliver the data to them, so which required different kind of connectors. If the systems are in the cloud, we may have to have a cloud connectors. If the systems are in on-premise or any other data centers, we need to have a different kind of application connectors to connect the data to the system and push the data to the system. And obviously this data can be fine-tuned data, could be a metrics data, could be any other, and a raw data, could be any other format that application requires. So required connectors to channelize this data to be delivered to the target application, which are information systems or the IT systems. So once it's reaching to the application, then application will understand the data, and then probably depending on the application and its capability, the application may present the data in a different format, different way, different meaning metrics to users, for users to understand on the human readable format. So basically over the period, the data that's generated by the machines are converted into the human readable data and more meaningful data and present to the user for better understanding and better insights about what is happening on the factory floors. So this serves the whole purpose of taking the data and making it available to the globally, and as well as presenting to the users in more meaningful way. So at the minimum, it's not like this is standard. These 7 layers are not just a stand. It's not a standard, but at the minimum, to build a IoT based application or solution for any customer, we require 7 layers of the modules or components to handle a different level of data processing or data distribution aspect of it. So we definitely need any system that we need 7 layers of data processing in the IoT solutions. But we are talking about industry case. So, but more important, right? Of course, physically we can read the data from the machines. We can take it to the cloud. And of course, cloud has a lot more capabilities to processing the data and storing it and delivering to the systems. But in between, the most important critical part where most of the IoT projects fail are related to the connectivity aspect of it. Picking the right connectivity for the right use case and the scale is very critical to make sure that the data is delivered to that. If the connectivity is not stronger enough, scalable and sustainable enough, then the data may not be available on the cloud, and obviously that will result in irrelevant data in the cloud, and users may see the old data, and that result in not even serving the purpose of the whole implementation. So picking the right IoT, the connectivity or the network is very important for the use cases that we are trying to address it. There are various IoT connectivity available. in the market, from as this market is very strong and picking up with the various new innovations happening here. Technologies from the most popular technologies from 3G, 4G network to LoRa network to other radio frequency network available in that. But generally, in industry cases, we are not talking about general IoT. I wanted to specifically talk about the industry cases where we have to capture large volume of data. In the industry cases, the machines are capable of producing large volume of data, and those data are like a machine running data, machine, overall machine, different parameters that the system can generate. Typically, we have seen that the payloads that's coming out of the machines are heavy, huge, and a lot of repeated data and delta data as well. So we have to, when we are shipping those data to the cloud, obviously, we may not able to ship. We don't need to ship everything, but at the same time, we need a stronger connectivity to deliver it. And obviously, most of the industrial use cases, the industries are distributed in various regions and different locations, different type of connectivity. So to answer this question, right? So to take the data from the factory network to the larger corporate network for business users to look at the data at real time, we need to think about how we are handling the data, what kind of network that we are building on the factory floor level locally, and what kind of network we are building or network that we need to take the data to the corporate network. So the connection between the LAN network to the WAN network, basically delivering to the corporate, require various level on that. So the volume of data, right? If it is a wired connection, volume of data, the rate per seconds, or as you can see that the Ethernet network supports up to 10 Mbits, and Wi-Fi network supports 50 Mbps or 54 Mbps, or depends on that. There are a lot of it's not a standard one. That is just example numbers. Some of them are example numbers. Depends upon the routers and the things. The numbers might vary. But obviously there are the UWB, which is a ultra wide bandwidth radio frequency network, also supports different things. But generally, in the factory network, when we are creating LAN network or the Wi-Fi network, using a Wi-Fi network, we have to have a strong Wi-Fi bandwidth that available across the factory floor to make the devices to connect to the internet quickly, faster, so that the data can be faster delivered, which is very, very critical on that. And those cases, we may not able to use LoRa and other network because of the volume of traffic is huge that coming from that missions. So we need to have a bandwidth and the rate of distribution higher to handle that. So we are looking at, in our use cases when we are going for factories, we typically look at the wired Wi-Fi network to see whether the factory floor has a strong band of Wi-Fi network or wired network available to connect the machines or connect the gateways to the internet. Obviously, if that is not possible, or that there are cases where it may work within the LAN network as a routers, but when you're taking the data outside of the factory, there may not be any network available to do that. So obviously, we need a different wide area network or the global network that take the data to that. So again, it depends on the use cases. It depends on the volume of that, the number of machines being connected, the data being produced by the machines. We may pick from NB-IoT to all the way to the 5G network, depends upon that. The volume, the more larger volume of IoT implementation, the better to go with the 3G, 4G network, or even the 5G network if it's available. And the smaller volume of the the device or machine connectivity, probably go with LTE-M or NB-IoT, and depends upon that. And obviously, how much data is being produced per day, how much data needs to be important to be transferred to the cloud, how fast we need to deliver to the cloud. All of them is important. But one basic rule is that the purpose of building IoT solution is to take the data at real time or near real time to the cloud, and then distribute to the users immediately available, right? It is not for batch processing. If it is a batch processing, then obviously we can do a different bandwidth needs to serve that. So the whole purpose of going into IoT is to get the data at real time and serving at the real time to the business users, obviously, which require a different bandwidth of network. So we previously conducted a exclusive webinar about IoT connectivity, different kind of IoT connectivity and radio frequency, and different pros and cons on that. There is an exclusive video available in our YouTube channel. If you haven't watched this before, you can go and watch that, as I'm not going to cover everything here, as we already covered that in the previous webinars. Now, just trying to put together, right? So what we have talked so far in terms of the layers of the IoT, and then how we can break that into different pieces. Obviously, we start from the edge device. We need some kind of a router, IoT gateway, or edge solution, hardware solution, or the component solution that we have to deploy it on the factory floor or the local network to fetch the data from all the machines. Obviously, OPC UA, or you are using Modbus, TCP/IP, Modbus RTU, or Profinet, or CAN bus, whatever the networks or protocols supported by the machine and systems controllers. We need a corresponding device or gateways to read the data, understand the data, and send it to the cloud. So picking the right device, or the gateway, or the controller, or the software or SDK that we build is very important for the right protocol supported by the machines. So once we solve that problem, then we have to build the connectivity cloud gateways. But on the cloud side, we may have to have more detailed process on that. So on the cloud side, so we may have to build cloud storage. We need a cloud storage. Obviously, we cannot directly take the data from whatever coming from the machine to the manufacturing or information systems, right? Like a ERP system, we cannot take that directly to that. So we need a storage for intermediate storage, or maybe a permanent storage to store that first before lose the data, or before push the data to further, and then process the data, cleanse the data, remove unnecessary things, or maybe extract the required data by the business users or the business systems, and then identify the key insights, maybe running an AI ML process, extracting the information that we required, or maybe a simple business intelligence based metrics that we build out of that. And those metrics can be served to the applications through the data services. So data services are nothing but the services or the connectors that we provide to take the data to different applications. Maybe we have to have a solution visualization tool within the IoT solution itself, or IoT function itself, for us to locally present to the administration team of that, right? And then finally deliver that to the app system. So we need all those blocks to build that. Obviously, these blocks are basic foundation blocks, and of course you can further break down into multiple level, and depending upon the use case, depending upon the scalability that you want to achieve, you need to take a call on that and how you would design it. But this is the base foundational modules that you should have if you are building any IoT solution for your organization or your customer organization. Now let's go into that, what is available in the market, right? And let's take a look at that, how we can achieve these different modules by using existing services, as we talked about. Initially, let's compare with the existing cloud services and providing that. Of course, the intention of this session is more providing on the cloud side, not solving on the edge device IoT hardware side of that. If required and you need such sessions, we are most happy to conduct an exclusive session on the hardware selection aspect of that. Probably that could be our next webinar as we are concluding this one. Let's take a look at how do we build a cloud solution. Yes, because this is the most critical one, under the time-consuming one is to build the cloud infrastructure to process the IoT data or build the IoT solution for our customers. So let's start with Azure, Microsoft Azure. I have taken the Azure recommended reference architecture. Of course, it's more on the general IoT reference architecture, not any specific to industrial cases. But generally, we can use this as a reference, as this is most commonly referred by, recommended and referred by Azure. So now, if we are building IoT solution using Azure cloud provider, what are the different options that we have, right? So by looking at this, obviously we have to handle on the device side, in our IoT gateway side, which is very important. And then we need to have a cloud gateway to receive the data in the cloud. We have to have a data storage. We have to have a data processing. We have to have a connectors to distribute the data to the application systems visualization purpose. So take it from the left side. So obviously Azure provides various options for building and solving the data connectivity within the machine side or the device side. So Azure provides Azure SDK for connecting to different type of devices by building your own hardware and then deploying the SDKs into that and customizing the SDKs to meet different requirements. Azure also provides a different pre-built security protocols and controlling edge services to deploy it and process the data locally itself within the premise itself before you send the data. So Azure SDKs are very useful. Azure IoT Edge is very useful to build a solution. Depends upon the use case. If is it necessary for you to build the edge solution to reduce the volume of data that's going into the cloud, or is it just simply enough to send the data directly to the cloud? It depends upon that. You can go through Azure Edge, or without Edge also you can send the data directly to the Azure cloud from the on-premise or from the machines. On the Azure cloud side, you have options. We need a gateway. So Azure providing IoT hub for that, which is a gateway for sending the data, making the device to connect, and to provide access for the device. Azure also providing device provisioning services and digital twin services. Of course, if you need a digital twin services, you can leverage that. But generally, basic IoT level projects, it doesn't need digital twin, which is more advanced level. Obviously, we can use the IoT gateway and provisioning to validate the device and receive the data on that. Once you have the data, then probably you need to send the data to different purpose, right? What is your purpose? You wanted to immediately process the data on the fly. Is it important that you need to process that immediately on the fly? Then you need to go to the hot path to stream the data to the streaming analytics services and process the data through Spark and Storm technologies, and then deliver the data to your business systems. They are not that critical. Typically, the critical data are mostly alarms and fault that coming from the machines, and those kinds of data are immediate attention is required. So maybe they are all the good candidate to send those data to hot path. If you are going more, if your data is more of operational data like machine running time, machine productivity time information, then they are all most of the cases it's warm path can go through warm path, means this can be stored in the time series tables, and you can process that insights and take the data, extract the data, and push the data to any other business system. That's a warm path. On the cold path, if the data is more like end of the day processed data or data that are already processed that you wanted to push, that you may do that with warm cold path. Mostly the data required for ML purpose, we keep piling up those data in a cold path on the blob storage, and then using ML process provided by Azure to process the data. And obviously you can use different tools, technologies within Azure, as well as third parties provided services within Azure to handle different kind of use cases. So obviously Azure provided 3 different ways for you to handle 3 kind of use case data types, or the data type of data that coming from the machines, and push the data to the business systems through the APIs or through the connectors that they provide. Obviously you can build your own applications using their app builders, or you may build a logic there, you may provide a search options or different use cases, then you can achieve it. Obviously Azure also providing a way to send this data to other systems through the API gateway. So obviously, by looking at the model that we looked at that, so Azure providing everything that we need to receive the data, to process, store the data, to process the data in a different stream, and then push the data to the different applications. And visualization part also, you can build the apps in Azure itself to serve to the users. So all of them is providing, but everything, you need to pick and choose what you want. It's all independent services. You need to pick and choose, and you need to assemble all of them together to make the uniform solution out of this. So more there are varieties on that. There are various use cases can be achieved, and also it's required assembling work by the team of IT people to build a solution, end solution for the business users. Now moving into AWS. AWS, obviously it's very complicated. They're providing a lot of variations, lot of services compared to Azure. But it's all integrated services, means they're all connected together, but different variations. So let's start with the edge device side, industrial environment. So AWS provides similar to the edge. AWS providing edge services like IoT green grass that build the edge functions within the system, within the on-premise system, maybe using hardwares, any recommended hardwares. Or you may use the storage capacity to capture the images and store it locally and then push it as a bulk storage, or making a video streaming data through Azure Panorama to get the data and then pushing to the cloud. So there are options. So you can read the machine data, you can get the images, via clipping and images from your cameras, or you can stream the data as a video streaming data to the cloud. So three different ways that you can, different type of data that can be collected and sent to the Azure AWS cloud. On the cloud side, obviously, again, similar to Azure, they have IoT gateway, which is IoT core, which receives the data, and then provisioning system is there site-wise, and then you can process the data immediately, or you can push the data to the data lake, which is obviously Azure S3 buckets, where you can push the data and then you can process the data with the help of Azure pipelines or Lambda functions, or you may push the data to the contextual DB, which are like a Dynamo DBs and all. So obviously within the data lake, you can store the data, process the data, identify the insights. You may also use the AI services provided by them to looking at the equipment performance, anomaly detection, all those stuff are pre-built. So you can use those services to detect any information. And using Lambda functions, you can deliver those data to any other systems, obviously any other applications, or using their gateways, API interfaces also, you can deliver to any other applications like ERP, CRM systems. So obviously, there are different components available for different reasons, but little larger size and also different variations, but all are tightly integrated with that. So easy to use, but at the same time, you need to decide what component you are going to use and how you're going to build your application, IoT application or IoT platform, or IoT solution based on these components. So again, it's up to us, the architect, who has to decide on what is important based on the use cases, based on the customer environment, based on the customer need, the scalability of the project. All are the variations, all of them are the input to decide the right architectural model on that. But fundamentally, everything is same as we looked at earlier. Google Cloud, in my opinion, Google Cloud is not as extensive as Azure and AWS in terms of the IoT device management. But Google is very good on providing data services, data aspect of that. Obviously, Google providing option for us to send the data to the through the IoT core, which is again the IoT cloud gateway, through which you can take the data to the internal storage, which is obviously cloud storage, where you can place that into big data, big table, and using big queries you can build the functions, and those functions can be delivered to the data, to the visual systems through Data Studio or Data Labs and other things. But in my opinion, Google architecture is more focused on the IoT data processing, quick and easy way to process it, and building an AI solution out of that, rather than solving the device management standpoint. So if you already have platform solution, or you are using some third party to send the data, and your intention is to build the IoT data management and AI using the IoT data, then obviously Google would be the best option on that. But if your intention is to build the device management also, then you may have to look at more on AWS or Azure IoT services. Obviously, you can see that same model, same pattern. So you have a gateway, you have a storage, you have a processing engine, data processing engine, you have a AI insights, query parameters, and data processing, and then results, storing it, visualizing it. So all of them is same pattern. So by looking at all three, right, so everything is common, right? Everything is very similar pattern, but the different modules provided by them for different use cases and purpose. Now now we are coming to that. So what we are providing is again, obviously the standard is same. So we are also providing a edge SDKs. We are providing SDKs in our side in Fogwing. But the one biggest difference in Fogwing is that Fogwing is a no code IoT platform, which means that absolutely we are trying to avoid the users to write any code or any level of that. So it's easy, faster to configure. So it's a completely no code platform. We provide SDKs if you want to build a custom solution on the edge level. Of course, that's a programming level. You need to build that on the hardware side. So we provide a SDKs to help you to build a connectivity to the cloud, and any device can be connected. We don't have any restriction in terms of the type of devices or network that can be connected to our cloud. So as long as the IoT gateways or devices or edges that capable of connecting to the cloud, our cloud, sending data to the MQTT servers, it can connect. Obviously, we also have our own edge servers, which are pre-built with OPC UA connectors, and handling a different type of machine connectivity. They can read the data from the SCADA systems, they can push the data to the cloud, or they can read the data from the machineries, which supports OPC or Profinet, other different protocols. So we take the data and then push it, and then obviously we do some kind of a cleansing work at the edge server itself. So we have a dedicated edge services available for our customers to use that. On the cloud side, of course, we have an IoT gateway, and that's a way that all the devices can be connecting. We have a device management through our internal repository registries, and we provide the access to the devices, control the access level on the devices. All of the provisions is there. Obviously, we do have an integrity check by default built with our platform. So any data coming in, we always check that to avoid any intruders sending any other spam data into the systems, or any of the script to the systems to avoid it. So as a security check on the gate itself, we have a inbuilt integrity check to make sure that the data that's coming is accurate enough and properly structured data, so that we are processing it further. If the data are incorrect or coming any other in non-standard formats, and those data will be ignored by at the gate level itself. So we provide that. And then on the data processing side, of course, inbuilt with our platform, so we have a data validation checks. We can check that. We have a data filtering through our functions, attributes, functions. We can also enrich the data using our data enrichment functions, and obviously we store all the data after that. And rules checks, to check whether the data has any parameter that you want to check the data before that you process the data. So all of them are inbuilt as part of that, and it's not like everything that customer has to build it. Everything is in the flow and configurable through our web portal itself. So users can, or customers can use that solution to simply build the data capturing and data processing faster. Obviously, we support a hot and cold storage similar to Azure. In fact, we have hosted in Azure, so we leverage the Azure infrastructure to run it, but we don't use any Azure IoT services. We have built everything as our own to handle the no-code requirements. So obviously, we have a hot storage and cold storage. The data will be stored in the hot storage for a year, and then cold storage after that a year, and lifetime storage. And obviously, we have a connectors to send the data to any other cloud. We have an API gateway to send the data, or any other system can extract the data from us. Obviously, every data that we are storing is in time series basis for our analytics visualization systems. So even in our platform, if you look at that, we have a edge side, we have a device management and gateways device management. We have a storage capacity, processing capacity. We have inbuilt insights and actions, and we also have the visualization tools to use it. So we also follow the same pattern to serve the customers, but we are a 100% no code platform for users to build the solution faster. So what is common, as we saw that edge SDK, all of them providing, cloud gateway, all of them providing, storage provided, data services provided, visualization provided, everything is done as per the structure that we have seen that. So everything is common, right? But what is the difference, right? How it is, how we are going to differentiate it. I will talk about that as well. In terms of the tech stack comparisons, obviously you can compare it. We already have this model. You can review this also in our blog, and we do have an exclusive blog on this particular topic. So on the communication protocol side, of course, Fogwing supports MQTT, REST API, UDP. AWS supports similar structure like a HTTP MQTT. Google support MQTT, and then Azure supports. If you see that commonly everybody support MQTT, especially industrial use cases, we highly recommend to use MQTT for continuous connectivity, continuously feeding the data, faster data capturing, and then seamless communication and lightweight packet data transfer. So MQTT is the best, and secure MQTT is the best option for us. So we by default providing, but obviously some of the devices may not connect in other protocols, so we support UDP as well. And on the core functionality side, of course, as we have seen that, AWS, Google, Azure providing different type of modules, components for you to assemble together. But everything we build it as inbuilt with that platform. So we do provide a similar connectivity, authentication, device management, monitoring capability, inbuilt rules engines, inbuilt development mode, and SDKs, everything. Data handling also, of course, we have Azure, AWS, Google providing different services at different phases for different purpose. We also have the same inbuilt queuing mechanism, but obviously you may not know that there is a queue because it's all inbuilt with that. So we don't need to worry about how the queue is structured and how the queue is delivering data. So we have abstracted all of them, and all you have to do that just to take the data, what you want to really do that, and the data processing, you just need to configure that. Main difference is, we are our platform is again, is free to start. Obviously everybody is free to start for you, but you pay only as per the device counts, how many devices you are using it, pay on that, not like based on services you are using, like other AWS, Google, and Azure. But obviously they are all having a different pricing, different models and things. Where we are very well fit into that, we have our system is very easy to use for a smaller use case or medium size use cases. The larger use cases can also be achieved, but little more customization. Obviously that's where we come in and help the customers. Obviously we don't need to talk to us, you can just go and use it like other services, like like if you're going in Azure, you can just go and register and you can start the work. Same way in Fogwing as well. So everything pretty much similar what we are providing comparatively to that, and we are making it simplified for the non-technical people to understand it and then use the system platform in that. But the main objective is, where is it, when we should go with Azure, AWS, Google, honest opinion, and when you can use the Fogwing platform, right? Because there is a difference on that. From the scalability standpoint, from this infrastructure standpoint, it's pretty much same. Obviously, but there is the way that we are differentiating is in a different aspect of that. So there's no direct pros and cons. It is not direct comparison of saying as pros and cons, but pick the one that suit for your need, especially your use cases, and how you wanted to, what kind of size and scale that you want to build it. So let's take where the customer can go into AWS, Azure, Google Cloud. If you have a good, strong IT capability, you have a team of developers who understand different services provided by the Azure or AWS, Google, obviously you can go for that. But before that, if you are going for large volume of device development, you are deploying large volume of devices at the large volume scale at the initial phase itself, and there are various large use cases that you need to address it for a specific customer or various customers. The use cases can, in the enterprise level, use cases are different aspect, different users, different scale globally. You want to serve it, all of them. If you need it, then you can go for that. If you have a stronger budget, as the initially it may be lower, and as you build it, the budget might shoot up. So you may have to be ready for the 5 years budget plan before you step into build in Azure, Google, or AWS. As you invested time and effort to build the solution there, obviously you need to have a stronger sustainable budget to run the solution for a longer time of period. Obviously, to assemble all together and build all of them, you may need a months and months of time to build that. So if you have a time, if you have a budget, if you have a large volume of use cases, if you have an enormous amount of use cases that you need to solve in the large enterprise cases, and the strong IT capabilities with the strong device, hardware, wireless communication, cloud data processing, and application level, you need to have a skill set on all the level to build a solution there. And obviously in Fogwing side, Fogwing is made for smaller team, for a smaller, start with smaller name. Of course it can scale even 10K to 15K devices, no, never mind, it still can scalable, and we scale our infrastructure based on customer usage. But obviously you can, this is start small and build larger. in cases where you can definitely utilize the Fogwing. So if you have a small team and less expertise in IoT, but you still want to build IoT solution, obviously, Fogwing is the option for you to start easily, as we are no code platform. Obviously, if your use cases are very small initially, you don't know that how big it is. And your use cases are very small, but you want to build small, solve the small problem, and then go to the larger problem. Yes, obviously, it is easy for you to build that in Fogwing. And industrial cases, we are not built for general IoT use cases. We explicitly made for industrial cases. So if you are building an industry specific, domain specific IoT solutions, obviously you can use it. And smaller budgets, just start with a smaller budget and build the solution, prove the solution, and then scale up from there. And obviously the short time, as we are a no code platform, you don't need months of time to create a cloud infrastructure. You just need hours of time to build the cloud facilities and process your first device data within a few hours of you are ready to go on the IoT solution. So that's the way that we are differentiating. Obviously, the large volume, larger enterprises, larger need, you need more customizable, more flexible system to build it. You need to go for larger platform provider which provide different services. So you need to pick and choose and assemble it. If you are starting small and then scaling up from there, but you need faster time to build it, you can leverage Fogwing platform for your use cases. That comes to the conclusion of this session. And of course, we have covered the basic need of the modules, and then purpose of that in the industrial cases. Obviously, to summarize that, we compare Google, AWS, and Azure with Fogwing. And obviously, we have honestly put together the where we stand, where the other products platforms are stand, and where is our sweet spot, where is other products are standing and their sweet spots. And obviously, you can leverage our systems if you are looking at large case use cases. Not only that, Fogwing is a cloud infrastructure which also provide other product and solutions for industrial cases like MES systems, asset management systems, and those application systems are also provided by that. So it is not just for IoT platform development, it is also for the larger use cases are pre-built with that. With that, I'd like to hand over to Abhishek. I hope a lot of questions are there. So let's jump into the questions and answer it as we are coming to the near closer time.
Thank you so much, Hari. Great presentation. Yes, we do have few questions aligned. I think there were a few discussions also happening. So I'll quickly jump into the questions. So what is MES in this particular hierarchy? At what level MES placed?
Oh, okay. So let me go back to the industrial systems. Okay, so let's take this. Yeah. So MES comes into the layer between the physical systems, which is obviously PLC SCADA systems, and then the information management systems that are in the business side of that. Typically, the information systems are for business users. To use the business function, business operation, like a sales order capturing, work order capturing, work order, and then customer relationship management or finance, those kind of scenarios. The shop floor systems like a SCADA, PLC systems are more intended for machine operations. So in between, if you have to have a visibility in terms of the execution of the production, then you need a system such as MES, which play a role between the information system and the physical systems in the environment. Obviously, MES is critical for larger manufacturing companies to plan and execute, production operations efficiently. But at the same time, the connectivity is also important for taking this data, even including the MES, maybe hosted in cloud, like a Fogwing S-Factrix MES, which is hosted on the cloud. The data required from the physical environment. So obviously, we use IoT to bridge the gap to send the data to the MES system. And since it's a cloud MES, both shop floor users as well as the corporate users can use the system on that.
Thank you, Hari. So I'll move into the next question. For tiny spaces, can we include Bluetooth, NFC, etc. as part of IoT connectivity?
Uh, no, not really. Even if the tiny places, Bluetooth or NFCs are not that reliable compared to because Bluetooth or NFCs go on sleep mode when there is nothing happens and require a wake up call to trigger that. In terms of if there is a ideal situation in the missions and there is no data produced, if there is no data transmitting through the Bluetooth or NFC, obviously that the protocol goes into sleep mode, which basically disturb the communication channel. And it is, in my opinion, it is not highly recommended for the industry cases. It may be useful for home automation or personal automation, personal IoT needs, home automation, healthcare sectors to detect the human pulses and other things. Those cases, it may be useful, but obviously, I don't recommend that for the industry cases.
Thank you, Hari. And there's one more question. The purpose of wirelessness actually gets defeated when we need to supply power to each device using wires. Is there a way we can find a way around this problem?
Can you repeat the question again?
Sure. The purpose of wirelessness actually gets defeated when we need to supply power to each device using wires. Is there a way we can find a way around this problem?
Ah, okay. So end of the day, any equipment need power, right? Even it's a wireless device, still need a power. Either the power may be provided by the internal power supply system, like a battery packed system, or required a external power system. Obviously, this is defeating the purpose of wireless. But the intention of wireless is not on the making the device to wireless. The intention of the wireless is to make others to connect. So the system which handle the wireless obviously should be in the power mode, either battery power, solar power, or whatever different way you calculate it. It provides other devices to send the data to the to the router through wireless. But obviously, if you need a longer power, longer life of the battery, or longer life of the sensing data to be coming up, you may need to go for LoRa or UWB based network, which is a low power consumption one. But of course, the power consumption are lower because of the data transfer is lower. So if you're having a heavy data transfer, you obviously you cannot use those protocols. So these are really tricky, challenging things. It depends on the use case, depends on the data, how rapidly we have to send the data, how volume we have to send the data, as I talked about before. And obviously, power is a basic thing, either inbuilt battery or external power, either wireless or wireless. This is how it should be handled. And good question on this.
Thank you, Hari. A few questions I have received on Fogwing. So I'll just move on to that because we already are exceeding the time. So the case studies of Fogwing implementation. I think there's a question people are asking. What are the case studies of Fogwing implementation? And then device volume that Fogwing can handle.
Oh, okay. So I think we are so our platform is a multi-tenant system. So obviously, you can start with small. That's the purpose of providing multi-tenant, to start small. And obviously, we have customers using hundreds of devices connected to the platform, individual accounts. But the overall, the platform is right now, the infrastructure that we provided is capable of scaling up to 10K in the multi-tenant itself, up to 10K devices connectivity. Obviously, we have built, as I said, we have built it in Azure, which is highly scalable. By default, the system is scalable. As we are measuring the multi-tenant users volume increases, we also scaling up the infrastructure, underlying infrastructure, to make sure that handle the volume of the data for the multi-tenant. But if you are a customer, and or if you are looking for a high volume of data for yourself, and you don't want to use a multi-tenant environment, you can obviously go for a dedicated instance from us. And you can in the dedicated instances, of course, the minimum level is 1,000 devices can be accommodated as a minimum. And if you are looking to scale up from there, we can obviously increase your scalability also, as this is a cloud infrastructure. We can scale up to meet your needs. So to answer the question, it is scalable by default. The multi-tenant supports up to 10K environment right now. We are not in that range right now. Obviously, if you are looking for a larger volume, you can also use dedicated instances, which are obviously scale up as you need. The whole platform is scalable to meet any large volume use cases. And the industries, right? As we said that Fogwing is intended for industrial use cases. So obviously, in industrial cases, the data are high traffic data are coming. So we provide supports on that. So it's we expect the data to be coming in high volume. Therefore, we provided the gateway infrastructure to consume to receive the data. That's number one. Obviously, the industrial cases, the ultimate data should be delivered to the systems in place in the organization, like the MIS system or ERP systems. So we provide a connectors to deliver the data, or you can take the data to any such systems. So it is not intention of storing all the data within the Fogwing. It is storing the data in other systems also, but obviously visualization is provided. So we have a minimum visualization purpose to see the data volume and other things, but not like intensive visualization, which we recommend you to use the existing enterprise systems like a BI system or any ERP systems to visualize the data on that. So our intention is more on industrial cases, as I said, and Fogwing platform can be used as an intermediate layer between to connecting the IT and OT infrastructure.
Thank you so much, Hari. And I'll just quickly ask you one more last question. Can we move from Fogwing to, for example, AWS at a later point in time?
See, obviously, you even if you are building a solution in AWS, you cannot move to Azure just like that. If you are building in Azure, you cannot move to Google Cloud just like that, because they are all proprietary solutions. There is no industry standard solution that you can move from any cloud platform to another platform. So in Fogwing, obviously, as we said, there is no coding. So obviously, it's all configuration storing inside that. You can take your data. Obviously, the data are stored in a plain simple format. You can take your data from Fogwing to any other cloud later point. You can start with Fogwing. Later, your business is grown. You are building a larger volume of data, and you want a AWS kind of scenarios. Obviously, you can take the data to any other cloud and use that there as well. But you may not be able to port it anything from Fogwing to any other cloud platform like other platform as well, as there is no code to port.
Okay, Hari, I think I can squeeze in one more question. What type of IoT device can be installed on a ship where there is no internet bandwidth for 20 to 25 days and deploy ML model of object detection?
Oh, okay. That's a very okay. That's a good question. So in a ship, especially the ship that are roaming around the sea, right? There is no internet, Wi-Fi, or any 3G, 4G network. There are companies providing a satellite network for such purposes, and you can use a satellite network. But obviously, volume is the biggest cost on that. If you're sending all the data to the cloud, it is high cost traffic that goes through satellite. Obviously, it's also not supported by that volume like how we build it in the land infrastructure. So the best model is take the data first. Take the data initially, build a edge device, collect the data locally in your hardware itself, store the data, take the data physically to any cloud environment, build the ML model. Once you train the model, take the trained model back into the edge, deploy it on the edge, and then use that locally. So whatever data that is detected locally, and that can be processed locally in the edge level itself, and only you can send the metrics informations, like if you're sending obviously in the end of the day, or hourly once, maybe 2 times a day, you may send the data to the cloud for visualizing from somewhere from the land. You may send the metrics data, which is obviously small packets. You can send it in a day. Depends upon what kind of satellite provider that you are engaged with, what kind of volume that you are sending it. Still, there is an option to send the data out, but you need to restrict the data only to the metrics level, or kind of consolidated data, or key information alone. You send it as a smaller packet through the satellite to your cloud systems, and then you can visualize that from anywhere in the global.
Thank you so much, Hari. So I think it's time to wind up the webinar. So as always, we will be posting a recorded version of this webinar on the Factana YouTube channel. You can also, ask your questions on the comment section there, and we'll be, always answering to that questions. So those who are also seeking more insights on IoT, Industry 4.0, and Smart Factory, you can, check out blog page, visit www.fogwing.io/blogs, and then start exploring. And if you're also looking out for collaborations, you can reach out to us at sales@factana.com. So once again, thank you so much for joining today's webinar. We look forward to connecting with you again in our next webinar. Have a nice day. Thank you.
Thank you, everyone. Have a nice day.